Greetings, welcome to the 93rd class of the Tampa IIBA chapter. I'm gonna try to make this short tonight. We'll do two techniques. My voice is potentially falling apart. The fearless and intrepid Thea will not be with us tonight. She has a family thing going on she needs to attend to, so we will stumble on as best we can. I will shorten up the introduction, and there is a discount code if you choose to use Watermark Learning for your studying. We have Cliff leading the way and doing all our advertising and background support for these meetings. Yulia has graciously agreed to be our VP of Finance. She is doing a few things for the chapter. And Caitlin and Priscilla are members at large. Thea is usually the one who MCs the meetings and is super helpful in many ways. We are always looking for more board members. I am here to help give advice and share experience and guidance and so on. I often present on various subjects, and Yulia has been nice enough since she earned her certification to help me out and lend another experienced view to the proceedings. And I'm not sure this is totally updated, but a bunch of people have earned various certifications because of our study group. I think Ilya earned his recently and will be speaking to us on the subject along with Yulia next week. And that will be Thursday, October 5th. And with the introductions completed, we will go directly into the technique. One thing I want to share with you is there is a page on my website, and it's right here. If you go to rpchurchill.com and click on this link here, it'll take you to this page. It has all the same links that Cliff gives you every week in the chat, as he has helpfully done this week. And then it links to all the recordings of the classes which Cliff dutifully posts on YouTube every week after the class. And then we have the subjects and the link to where you jump in. So if you look here, this is the entire recording. These are the subjects. So we're talking chapter 10. And if there's an article on my blog, that'll be linked separately. And then that is the time in the same video you can jump directly to that presentation and discussion on that subject. So we talk about the different BABOK areas. These are links to their relevant episodes for chapters 3 through 8. Those are the main knowledge areas. We've also talked about chapters 1 and 2 and 9. So those links are here. And then we're on the second cycle of talking about all of the techniques in chapter 10. So the first cycle, here's who spoke. That's the link into the relevant video. And here's the same things for cycle 2. And here are the list of techniques. And if I've written a blog on the subject, it'll be linked here. Definitely do not rely on that. Know what the BABOK says. I just give extra background and a different take on things. But for purposes of studying the BABOK is king. Finally, we've taken a few weeks to have guest speakers speak on different topics, and each one takes up an entire week's presentation. They are linked here. You might have a LinkedIn and some kind of slide deck sometimes, and the actual link to the recording. All right. Let's talk about data flow. Oh, one more thing going back to this. I figured out today that after I did a recent update to my WordPress installation, it broke the plugin that lets you see code snippets. So some of these blog posts will not be visible. That's annoying. I will try to fix that in fairly short order. All right, can you see data flow diagrams?
Yes, we can.
All right, fantastic. We got that going for us. Let me try to make it a bit bigger. All right. So the main thing I want to say to you is that there are two major ways to talk about where data flows inside a system. And obviously, this is very IT centric. So not every technique is, but this one, of course, is. And what the BABOK refers to regarding this technique is a formal way that data flow diagrams are created. So there's a web page here. And I will go to that. You can see that. All right. I assume.
Yep, no, we're good.
So this is the way data flow diagrams work. And they don't show any logic. They don't show any loops. They don't show what the contents of each message are. They only show the sources and sinks and data stores and destinations, and they show the processes where things happen, and they show where messages and data items are transferred from and to. That's it. There is so much more information you can display on diagrams of any kind. So in reality, a data flow diagram can be, if you use a method that is not one of these, really can describe anything you want. But let's talk about what's in the BABOK first. So there are several different standard ways of doing it. Jordan DeMarco, Gene and Sarson, Gain and Sarson, sorry, and SSADM in Jordan and Code. So Jordan was a busy boy back in the day. And if you notice, for the most part, many of these representations are fairly consistent. They all show the flows just using lines with arrows, and the shapes might vary some, but not that much. So be aware of what you're looking at when you do these. One thing that these things do is when you're looking at complex systems, you might look at an overall flow of things, and then there may be more detail so you can drill down into certain parts of the system. And this link here tells you how to do that. So as always, yes, Visio is great. I do most of my drawings in Visio, and I do not do anything this way. I always do a bunch of other things. Computer scientists and system architects in the whole industry had to start someplace. If you look at what's it called? UML, this might be a part of UML. I forgot to look it up to see whether that's the specific case, but it's just one view and one standard that was developed, and this kind of thing became very popular. So we have, like I said, processes or these things, data flows or the arrows, and they're labeled or at least named. External entities or sources of data and destinations for it. And then there are data stores, which are databases or other repositories. Might be flat files, could be almost anything for these. So here are a couple of other examples, and you can drill down. These can be as complicated as you want, and they can be nested. Now, returning to the top level, the main thing you want to think about, sorry, the connecting lines aren't really coming through in this diagram. They're actually they're in black. Is they basically have to think SciPoc for all this. So where is it coming from? What's the input? What's the process? What are the calculations and transformations? What are the outputs, and where does it go? Who's the customer? Alternatively, anytime you think SciPoc, you can also think COPAS, which is SciPoc backwards. So you work backwards from what your customer needs or what the output has to be, and go backwards to figure out what you have to do to generate what is needed. So one thing I mentioned on the standard methods the BABOK refers to is it doesn't say anything about the content of messages and what forms they may take. So I actually realized I need to add a couple things to this article. So here's a little snippet of a drawing of a design for a paper mill that I did back in the late 80s. And if you notice, a lot of the flow lines actually label what's going on here. It's something about the amount of mass of pulp and the consistency. So that is amount of wood to amount of water, and there's probably also temperature information in there. And here are some more. It talks about just water flows going into seals and things like that. And so you can, and there is a standard key that talks about how this works. So you can put on any standard for what is traversing any flow. You can also make it look like a list of variables. You can talk about the format, and you can talk about the data structures. For example, if you're exchanging records and see, all the different items in a structure might have different data types and sizes, you can describe all that. Somewhere in here, let me show you one more thing. Hopefully you're seeing the new page here. All right. So I wrote a blog post about ways you can communicate between different processes. So in this article, which I will link into the article I'm actually talking from now, I will talk about it. And all of these are valid for any system you're doing. So I've done serial and parallel and TCP/IP, which is networking. I've done shared memory. There's a Q protocol that was used on DEC machines back in the day. High-level architecture and distributed information systems, otherwise known as DIS. I know the acronyms right. I can't remember if I have the words right. It's for keeping simulations with multiple parts in synchronization. And then there is memory sharing. So you write different processes right to common areas in memory. And there is a whole science to doing that without stepping on each other. Sometimes you exchange files directly, and the files will have different content. You will have different web APIs which send XML and other kinds of messages. You will pull and exchange things with databases. So there are a lot of other weird methods, screen scraping of say real-time systems or old mainframe systems, that kind of thing. So here we go. Some other ways of doing more ad hoc kinds of data flow diagrams are these examples. And these show decision points in different processes. We could label things that are happening in the flows. We have sources, we have sinks, or destinations. We have different operation switches and logic we can talk about. We have different types of data entities and other things. One other thing you can do on a diagram is you can mix physical entities moving in data entities moving, right? So you can have things moving on a factory floor, for example, or being talk about a transportation system, and then or a stock system, say for a store or some kind of retail outlet, and then you can show data flows and systems on the same drawing. You might show the lines differently. So physical flows might have solid lines, and data flows might have dotted lines. So the main thing is any kind of diagram will work if you make it clear and everybody understands what they're looking at. So it takes communication, clarity, and purposefulness. Here's another representation of a system. I often Thea loves swim lane diagrams. I tend to have users represented as standing by different processes. So I can't think of an insurance company that had departments of 50 people who would process all kinds of documents coming in that would collate them and ship them off to other departments to have questions asked about them externally, and then they would judge them or score the completed packets. So there's a ton of information you can show on these drawings. Here is a mix of architecture and flow, so it shows something about how it's all laid out, what the pieces are, where they're coming from, how they're all added together, some more about the layout and how they're used in a different system. So you can really represent things, and this shows all the data items and how they're summed and multiplied to get a final result for say 500 locations of a nationwide process. The most important thing is always to make it clear what you're trying to do. And there are no rules in the real world. In the BABOK land, when they ask you questions about this on the exam, they're only going to be talking about these. So make sure you're aware of the difference. Does anyone have any questions about that?
Do you ever put the mapping information, manipulation information, any of that kind of stuff in here?
Oh
Or
yeah. If I was doing any of these diagrams, so I've created some of these just for presentations like this, but other ones, there's a whole lot of background information and description that talks about what all this stuff is. Again, it's if you make the context clear and everybody understands it, and you get the results you want and the outputs you want, and build a successful system, then the method is good, whatever it is, right? And I'm just showing a range of things you can do. So here we're talking about data items or input data to different processes. I could talk about the forms of messages that are actually exchanged along these lines. I could give the names and then have a cue or some kind of key written out for the format all those messages can take, and so on. That makes sense, Cliff?
Yep.
Any
I
other?
was just looking at it for people like me to actually do the work. So much of the field stuff, the manipulation stuff is so relevant. That's what I live by. But
Yeah, if you need to talk to programmers as a BA, they will need to know for every data item. Let's go look at this. So what do I list here? This is a text CSV file I'm talking about here, and I pulled this bit of text out of documentation I wrote for level 2 real-time simulation-based control system I wrote for steel mills. Now, it might not seem very BA-like. There are more about IT and business systems or other things like that, but the ideas are the same. So there's a label of what it is, and it has a data type in here, right? So that tells the programmers and the users the format of the data. Now, this is a CSV file is just raw text with commas, right? If you chose to exchange these things as a binary file, then you would know that on many systems, integer would take up 4 bytes or 32 bits. So if you did a structure with all this information, integers might be 16 or 32 bits. Real numbers might be 32 or 64 bits. Doubles might be 64, reals might be 32. You want to have ranges for these things or know what the ranges are. So you know what kind of variable you have to declare. Now, if you describe this as a database table, it might be different. Like databases only have one kind of number very often. Some programming languages only have one kind of number. So you're giving up space, always having to store, if you have a value that only ranges 1 to 8 in a programming language, you might only need 8 bits or even less to represent that. But in a database, you'll take up whatever the biggest number is. But it's always a trade-off between simplicity and consistency, and also space. So there also, if you write out files in XML, then there are opening and closing tags. You have to talk about those formats. And again, there are all the other communication protocols that might have keys that say it's this kind of message. They might all be different sizes. So you have to know how to interpret each message that comes along. There's a lot of information that can go into this. All right, I think I've beaten that horse to death.
Actually, I remember the old days before the databases got better, that you actually had to know how much bit room to say and all that kind of stuff for each field and et cetera. Databases don't do that anymore, but the old days you had to.
Well, also memory used to be extremely expensive, so they made dates only 2 digits. And somebody estimated that even though we had to change a bunch of code to make systems work after a Y2K, and we spent zillions of dollars in effort and time and money to make those changes, we probably save more money by having these smaller, squished down representation for all those years. So it made sense, even though it was a painful transition. So in this case, let's move over to talking about document analysis. We may end up dealing with documents in a lot of ways. Documents may come into our process to be dealt with in some way. They may provide information. They can be very small, anything from a receipt to entire manuals or books or giant piles of records or court proceedings or contracts or order forms or goodness knows what, right? And they can be generated and passed around as messages within the system. They can be modified, they can be added to, they can be clipped down, they can be deleted, they can be created, they can be shipped off to other people, they can be archived, and so on. So anything that's moving through a process or consulted during a process is something you might need to know about. And there are tons of different kinds of documents. So we have manual specifications and contracts, and we have to understand what's in those generally as part of a discovery process to learn how existing processes work, right? And also how different machines and different business rules and different operations work within a business. And then we'll do things to the documents in the middle of the process. We will generate historical records, which we might analyze to figure out what's going on so we can improve a process or at least see how things have changed. Then existing organizational policy documents basically talk about business rules, and rules can describe operations or time limits or different costs or fines or other things that happen based on certain conditions. And then we have to know about statutes and regulations. And there is every other kind of document you can think of. So one thing I did here was talk about documents in every phase of an engagement. One thing I realized recently is and I may have already shared this with you, the BABOK really only talks about the first 4 items. So up through coming up with multiple designs and choosing the preferred one to go forward to implementation. The BABOK doesn't really talk about implementation and test all that much, so I'll be doing some writing on that. But anyway, as a BA, you should know what's going on in all the phases of a life cycle, and you should also, I think, participate in all the phases of a life cycle, because things that are learned during the implementation and test will affect things and feedback in the earlier parts of your work. So you should be involved all the way through to the end. And if you're not, if your people are not utilizing you and having you partake all the way through to the end, I submit they're doing it wrong. All right, so what you're doing in the intended use is actually defining the problem. And there you're identifying what you need to do with documents in a general way. So you might be modifying them, coming up with new ones, and so on. So you're coming up with a high level description or understanding of what's going on. Now, for the conceptual model, that's where you figure out what's going on now. And that means you might look at documents that describe the process and break down all the documents to see what's in them, if they're being processed and you're actually looking at information in them as they're coming into your system and moving through your system and then going out of your system. Also, if there is no as-is state, if you're starting from scratch and building something entirely new, the whole conceptual modeling work is really part of the requirements and design. So it's folded in there. You'll be thinking about all the things you might do and thinking about various components of what your solution will be. So requirements are driven by the business needs of existing and future processes in the people, right? And they will tell you what they are, and you work with them iteratively to figure that out. So you will examine documents in this phase with a view toward figuring out what you have to do. And then in design, you're going to be, once you've figured out what you need to do, you're figuring out in detail how you're actually gonna do it. In implementation, that's when people get down to the nitty-gritty of actually writing code and coming up with explicit processes that read and incorporate and process and calculate and then output the things you need. And then test and acceptance are obviously based on testing things to see that you've actually got what you think you were supposed to have at every phase of the process between every step. So if we think about the data flow diagrams we did, we want to test all those pointers between all the paths, make sure things have the right formats, make sure the formats are understood, make sure they're processed correctly, make sure the right calculations are done, the messages for the next phase are generated correctly, and so on until we get to the desired output. And that is what it's all about. Any questions? All right, it seems fairly straightforward. Somewhere in here, and I should actually include a link in that article. I talk about different kinds of documentation and just list every kind I can think of. So those are things I've written. Here's a giant list of all the kinds of documents I can think of. Some are actually techniques unto themselves, like a data dictionary and a glossary or a listing of business rules. Those are all kinds of documents, so I'll include a link in that article. Okay. The last question I'll get to, or the last topic I'll mention, is that next week, Ilya and Yulia are gonna talk about taking the exam, preparing for it, what it's like, what surprised them, and so on. So they will be carrying most of the water. Hopefully, Theo will be back to lead the discussion. And one other thing, we've asked you this before, is that think about different books that are important to you. If you have anything that you'd like to share or talk about it, dump it in the comments so people can be aware of it. If you're prepared to do that now, you can talk about some interesting books. I have a stack of them. I'm always partial to this one. Facts and fallacies of software engineering. I refer to it often, and that means that all these methods that we talk about, none is the killer app, none gives you the final answer. You always have to keep working and keep analyzing to get where you're going to go. But it says it in a much more interesting way. And I actually have a blog post about that book. So if any of you want to share books that are important to you, either do it now or post on one of the forums or LinkedIn or something like that in the group chat, or be prepared to talk about it in a future meeting.
And actually, we can mention it here too, is if anyone wants to take up a technique, feel free, let us know. We'll set up a date, time, or, Thursday night for you. You can present it right out of the
Remember,
BABOK. There you go. Thanks, Bob. You got your
here's
stick right
the
there.
list of what's been done. And it's updated almost every week. So there aren't many to do on this cycle, but there are a few I'd love to hear your thoughts on anything. And also, if you want to talk for a longer time about a subject, a specific job function or career or industry, or just tell stories, we'll be happy to give you an entire week to be a guest speaker. So Thea has found a lot of interesting people that have given us some great information, and from which I've learned a ton. All right, so I think we're gonna cut it short this evening in the absence of any further questions or commentaries. Hopefully, Thea will be back next week. As always, anytime you're listening to me, speed the recording way up. And I don't sound quite so horrible that way. Hopefully, the information's good, though. All right.
Thanks, Bob.
Thanks,
And
Bob.
we'll see everyone next week.
Sounds good. Thank you.
The website you put together, all the videos for the knowledge areas, that's super, super helpful. Thank you so much. Kudos to team.
You're welcome.
Yeah, I'll second that, Bob. That helps a lot.
Thank you. Good night.
Bye.